would like to think that you have watched The Price is Right ever since you were a little boy. Hold one chip flat against the board and put it in that slot for $20,000. Let it go. Here comes chip number one, and into $20,000. $20,000 with his first chip. You got that made. Now, do it again with the next chip exactly the same way. You've got the gouge here. Here it comes. Get over there into... Oh, what a bummer. Put that last one right there. You've already won 20. Let's make it 40. Here he goes. Push it off there. That's it. That's it. That's it. It's looking good. $20,000. Come on down, Ryan. You have won $40,000 on The Price is Right Prime Time Special, saluting the United States Army.
Plinko. A great game with lots of mathematics behind it. Basically, we're dealing with pathways. And if you imagine this to represent our Plinko board, we can consider asking ourselves the question, how many pathways exist for the Plinko disc or ball or whatever you want to call it to arrive in this location. Notice that the ball or the disc can only go down. It can't hit here and then bounce back up and come around. The ball has to come down as we play Plinko. So how many pathways exist for the Plinko ball to arrive in this location? There is only one way. The only way for that to occur is it had to come down and bounce to the left. Likewise, there is only one pathway that will allow the ball to come to this side. So there's one pathway to the left and there's one pathway to the right. And of course, when we started off at the very top, there's really only one pathway for this Plinko ball to begin. Now, in the Price is Right video that you saw, the ball could have gone anywhere along this whole starting section. But it still starts with one pathway to begin with. As we continue down then, we're going to look at each row in our Plinko table to really analyze this mathematically. How many possible pathways exist for the Plinko ball to arrive in this location? Well, there's only one. Because the ball, in order to get to this location, must have traveled to the left and then to the left again. You see, the Plinko ball will not travel to the right and then bounce all the way over here. It's just not possible with gravity pulling the ball down. So for the same reason, there's only one possible pathway into this section. So how many possible pathways exist here? Well, clearly the ball could have started at the top and come to the left and then bounced right, or it could have started by going to the right and then bounced left. So there are two pathways into this location. As we go along farther down this Plinko table, you can notice that the outsides, there's always only one way to reach that location. In order to hit this location, there's only one pathway that it has to have traveled. It had to have stayed left every single time when it was hitting the peg. So the question comes in which location should the Price is Right place their most valuable award? Does it make sense that they place the $20,000 prize in this location? Or, if you don't want the contestant to win, should you place the prize in a different location? In order to figure that out, we'd need to know how many possible pathways it takes to get to this location. So we're going to need to continue to fill in numbers into every location and ask ourselves how many pathways exist for the Plinko ball to arrive in this location. there are 3 possible pathways for this location, based on traveling left, left, and then right, left, right, and then left, or right, left, and left. By the same token, there are 3 for this location. Are you starting to see a pattern in any way, shape, or form for these numbers? Because as we get lower down, it's going to be harder to keep track of all the possibilities. I just traced out 4 for this location. I'm not going to trace this one out, but I know it's 6. And likewise, this one is 4. Have you seen the pattern yet? We know on the outside it's always 1. Where would you put that most valuable prize if you don't want the contestant to win the prize? Have you seen the pattern yet in our number of pathway options? The pattern is very simple. The number of options, the number of pathways for this location are based on the number of pathways above it. In order to get to this location, the ball must have traveled through this location or through this location. So there is 1 possibility of reaching this location and 4 possibilities of reaching this location. So then in combination, there must be 5 possible pathways to reach this location. Likewise, for this 10, there's 4 possible pathways to reach this location and 6 to reach here. So you either had to come through here or through there to get to this location. So you have 6 plus 4 or 10 different pathways to get to this location. If I continue to fill in my chart, I get the following numbers. Again, I'm adding the numbers above, the pathways that lead into this location. I add those options together, and that's how I get this value. And there it is. The most likely spot for this Plinko ball to fall is not on the outside. It's in the middle. It's most likely to fall here because there's 35 pathways to reach this location. There's 35 pathways to reach this location, but there's only 1 pathway that the ball must travel to reach this location. If I'm the Price is Right organizer, I don't want these fellows to win money. So I would likely put the most valuable prize on the sides. Now their Plinko is set up slightly differently because they had a wider board up at the top. But the same concept would be true as we calculated on the way down. Now mathematically, this numeric pattern is immensely popular and useful. And this is called Pascal's triangle. And here it is without the pegs. And of course it could be continued along to get the farther numbers down. Now it's used in many different ways, but just a couple definitions. First of all, this we would consider the first row, and this would be the second row. Notice that in the second row there are 2 items, in the third row there are 3, etc. Now these numbers can also be found using combinations. Now, you guys haven't studied combinations in any way, shape, or form yet. But to start you off, we could consider this value 3, choose 0. This value would be 3, choose 1. Three, choose 2, and 3, choose 3. Now, obviously, I pointed to the wrong values up above. There are 4 values in this pattern. 1, 2, 3, and 4. They match up with 1, 2, 3, and 4. 3, choose 0 is 1. 3, choose 1 is 3. 3, choose 2 is 3. And 3, choose 3 is 1. Now, a number of you are thinking, what does that mean? What does that mean at all? Well, notice the different fashion that we can write it in, okay, the different formats that you're going to see it. IB likes this format the best. You're going to see that one most often. But what it means then is 3 choose 2 means how many different ways could you choose two items from a group of 3 items? Well, if this was my 3 items, there's 3 items. How many different ways could I choose 2 of them? Well, I could choose star and square. That's one way. I could choose star and heart. That's another way. I could choose square and heart. That's it. Nothing else. There's no other options of the 2 items that I can choose. For those of you thinking, well, you could choose heart and star, well, we've already got heart and star. They're the same items, and we've picked them together already. So 3 choose 2 is equal to 3, which we saw on the previous page. 3 choose 2 is equal to 3. If we want to think about it in terms of N choose R, this means how many different ways could we choose R items from a group of N items. So, where does this work? Well, let's say we have 30 students in our class. And I need to choose 4 students to help me carry textbooks down to the library. Well, the question would be, how many different ways could I choose my 4 students? And 30 choose 4 could be done with this formula calculation. It could be written in IB format as 30 choose 4. Whoops. Not choose R, but choose 4. We could write it in this format as choose 4 from a group of 30. Or we could simply pick up our calculator and do it on our calculator. 30 choose 4 in our calculator. We're going to start by typing 30. We're going to press math. We're going to slide to probability. And you see N choose R. So we're going to choose option 3 and type in 4. 30 choose 4 is 27,405. That's how many different ways I could choose my group of 4 students to help me carry textbooks down from my class of 30. There's a lot of different ways to do that. Now, let's use 7 choose 5 without our calculator, but using this formula. Now, this formula is factorial. In factorial means, in this case, it's going to be 7 factorial over 5 factorial times by 7 minus 5 factorial. So let's just simplify what's inside the brackets. 7 minus 5 is 2. So we have 7 factorial divided by 5 factorial, 2 factorial. Factorial means take every whole number 1 less than 7 and multiply it with 7 until you get down to a value of 1. Stop when you multiply by 1. So this means 7 times 6 times 5 times 4 times 3 times 2 times 1. Stop there. Of course, if I continued into the times by 0, that would make everything 0. We're going to divide that by 5 factorial, which means 5 times 4 times 3 times 2 times 1. And that has to be multiplied with 2 factorial, which means 2 times 1. That's what that exclamation point means. It means repeated multiplication of every integer one less than the number you began with, down to 1. Now, of course, when we have a fraction and there's only multiplication, we can cancel items out, provided they're the same on top and bottom. So this 5, 4, 3, 2, and 1, 5, 4, 3, 2, and 1 are all going to cancel out with the tops 5, 4, 3, 2, and 1. So really all we have right now is 7 times 6 divided by 2 times 1. Well, 7 times 6 is 42. 2 times 1 is 2, and 42 divided by 2 is 21. Of course, we can also do that in our calculator by saying 7, choose 5, and that's 21. With that knowledge, you should be able to attack 6M, and I will see you again tomorrow. Have a good day.